Today we're going to be talking about combining like terms and the distributive property. We use these to simplify longer expressions and make them easier to work with and give us more information. So if I take a look at this first problem, 5x plus 2 minus 3x plus 7. What I'm looking for are like terms, and what that means is they have the exact same variables as the other terms. So what I'm going to do, the way I like to organize it, is I put things in boxes to start. So I know 5x is my first term, so I want to go ahead and look for other things that are like terms to 5x. So what that means is I'm looking for all of the other x terms. Now, if you have an x squared, that's not an x term. It's got to have the exact same variable and the exact same exponent. So if I look through, I know I have this negative 3x that's going to be a like term with 5x. They both have a variable of x. You'll notice that I included the negative in that box because the sign's really important. That sign is going to tell me how I need to combine those numbers. So I don't have any other x terms in this problem, so I'm going to go ahead and pick another shape. So I'm going to pick a circle. The next term that doesn't have any shape on it is that positive 2. So now I need to look for all the like terms for positive 2. So that means just the plain old numbers, the constants that are in the problem. So if I look, I have a positive 7. That doesn't have any variables on it, so that's going to be a like term with 2. From here, I just go through and I combine the things that are in each particular shape. So 5x minus 3x. We're only going to worry about the coefficients here. So 5 minus 3 is 2x. I always tell my students, if I have 5 kittens and 3 kittens get adopted, I'm left with 2 kittens. You just bring that x right along with you. So I then move on to the circles. So I have positive 2 plus 7. So 7 plus 2 is positive 9. And I've simplified this bigger expression into now a smaller expression of 2x plus 9. So when we look down at B is a little more complicated. We have a lot of terms here. So our first term is 4xy. So I'm going to box that up. And then I'm going to look for like terms. So the next one in my list says positive 2x. That's not going to be a like term for 4xy. It does have an x, but it does not also have the y with it. It has to have xy. So 2x isn't going to work. The same is true for positive 3y. Yes, they do have y in common, but we don't have the whole entire variable xy. I do, however, have that variable here for negative 5xy. I look at 4x and I know that's not going to work, and neither is negative y. So now I'll go back and I'll start again. The next term that doesn't have any shape is going to be positive 2x. I'm going to put that in a circle. And I'll go right down through my problem. 3y is not going to get circled, but positive 4x is, because that is going to be a like term. Both of them have an x. Back at it again. I'm going to put this one in a cloud. Positive 3y, and my negative y over here is going to be in a cloud as well. So now I just got to go right through and combine the things that are in each shape. So we'll start with our boxes. 4xy minus 5xy. Again, we're just looking at the coefficients, those numbers that are in front. 4 minus 5 is negative 1, and then I bring my xy down with it. I have a positive 2x and a positive 4x, which is going to give me a positive 6x. And I have a positive 3y and a negative y. So this is really negative 1y. So 3 minus 1 gives me a positive 2y. So we can also simplify by using the distributive property. We use the distributive property when I have a value outside of the parentheses and I want to distribute that through each term on the inside of those parentheses. What we're really doing is we are multiplying that coefficient times each term on the inside of those parentheses. So in this case, 3 times 4x is going to give me 12x. 3 times negative 1 is going to give me negative 3. And you'll notice that I keep using the signs over and over again. I say positive, negative. It's important that you are getting in the habit of doing that so that you make sure that you're using the correct signs. Because if I have a positive times a negative, that's going to be a negative, as indicated here when we had a -3. And that's going to change my whole problem if I don't include that. So another example here, I have this negative x as my coefficient, and I want to distribute that through each of the terms on the inside of those parentheses. Negative x times 6 is negative 6x. Negative x times negative x is a positive x squared. So we can put both of these together in more complicated problems. So if they ask me to simplify something like a, I know that I am going to first have to get rid of those parentheses, and we do that again by using the distributive property. So I would say 2 times the first term, which is 5x, would give me 10x. 2 times negative 4 is negative 8. This 2 does not distribute to the 6x. It's separated by a plus sign, so that doesn't get affected by that coefficient of 2. We're just going to bring that down, plus 6x. Well, now I'm back to figuring out combining like terms. I have a 10x here, and I look for all my other x terms, and the only one I have is this positive 6x. The only little lonely number I have there is negative 8. So 10x plus 6x is 16x minus 8. For part B, we have 2 sets of parentheses here, so I know I'm going to have to distribute more than one time. So we'll do it in order from left to right, and we'll distribute this negative 4 times 2x gives me a negative 8x. Negative 4 times positive 2 gives me a negative 8. So I have simplified that. And then I have to go over here. It's really important that we are using the sign that's with that negative 7 to distribute. So negative 7 times x is negative 7x. Negative 7 times negative 1 is positive 7. And again, we're going to box up our information. I have an x term here. I have another x term here. I have a number term, and I have a number term. So my final answer is going to be negative 8x minus 7x is negative 15x, and negative 8 plus 7 is negative 1.